Welcome back. During the course of our discussion today, we shall demonstrate how to solve simultaneous equations using the elimination method. Take a look at the question we have. Below are some simultaneous equations. Use the elimination method. I'm going to underline it here to find the values of the unknown variables in the two problems. Show you're working clearly. Alright, we already know the method to be used, that is the elimination method. So to solve these problems, let's begin by attending to problem A, solution. Now problem A, or the problem 1 rather, says A plus 2B is equal to 3 and 2A, look at the way I'm doing my arrangement, minus B is equal to 5. Before I start solving, I want to explain something to you. When you are given simultaneous equation problems to solve, the very first step that you need to bring to board is trying to arrange the equations in such a way that on each column, the terms that you arrange on each column should be the same as the term below. That is, the variable you are looking for should be arranged in such a way that that variable in the first equation will be directly below its relative in the next equation. And as you can see here, I have arranged the first equation in such a way that A comes in first. In fact, the question has arranged itself already in such a way that A comes first before B, and in the second one, A also comes first before B. So it's already properly arranged. I will show you why this is necessary. So, having learned about the first step, the next thing you would want to do is to name them in the equation form. So I'm going to name this equation I, while the second one becomes equation II. There is a reason for that also. The purpose is so that when you are making reference to any of the equations, we will easily know the equation we are making reference to. Alright, since we already know that the first one is equation 1 and the second one is equation 2, the next thing we are going to do is to see if elimination is possible. Now, mathematically, elimination can only happen when two terms are similar. What I mean by that is that I cannot eliminate the A term right now because in the first equation there is just one A, but in the second equation there are two A's. They can't eliminate each other. The only way for a term to eliminate another term is when both of them are equal, because elimination mathematically means reducing to 0, using one to kill the other one without anything remaining. Okay, so let's find a way to equalize a term before we can eliminate. So if I want to eliminate the term A in these equations, I will need to equalize them. Below, I already have 2A minus B is equal to 5. So I will try to equalize the one in equation 1 to become 2A as well. And to make that happen, remember this is an equation. Whatever happens to the left happens to the right. So it means I have to multiply the equation 1 by 2. That will change the 1A to 2A. So that's the next step. I am going to multiply equation 1 by 2. And if I do that, that will generate a new equation for me. 2 multiplies A gives me 2A. 2 multiplies 2B gives me positive 2B. Sorry, gives me positive 4B because it's 2B. And this will be equal to 2 multiplies 3 will give me 6. Now I'm going to refer to this as equation 3, which we just derived from the first equation 1. Now looking at equations 3 and 2, you notice that the A term in both equations are exactly the same. 2A in equation 2, 2A in equation 3. Now elimination is possible. So to eliminate, I am going to subtract equation 3 from equation 2. If we do that, this is what is going to happen. Minus 2A minus 2A will give me 0. I have just eliminated the A term. But negative B minus positive 4B is going to give me 5B. in the negative form. Alright, equal to 5 minus 6 gives us negative 1. So we end up with negative 5b is equal to negative 1. What is the next thing to be done to find the value of b? We divide both sides by the coefficient of b. And right here, the coefficient of b is negative 5. So I will divide the left hand side, which is negative 5b, by negative 5, while I will do exactly the same thing to the right hand side. The negative 5 in negative 5b cancels out the negative 5 below. So we are left with b on the left hand side, and on the right hand side you divide the numerator and the denominator by negative 1, so that the negative signs get cancelled out, and in that case we are left with 1 all over 5. We have just ended up finding the value of b, which stands as 1 all over 5. Now, since we are using the elimination method, I am going to redo what I have just done, but this time I will try to eliminate b instead of eliminating a like we did in our first example. So pay attention. I'm going to recopy equations 1 and 2, which were our original equations. Then I will try eliminating b to find the value of a first. So let's do that again. I'll go back again to the question and I take it down here. A add 2b is equal to 3. That was our equation 1. And for the second one, 2a minus b is equal to 5. That was our equation 2. Right now, what I am going to try to do is to try to eliminate the b term, not the a term this time, since I already eliminated the a term to find b. Now let's eliminate the b term to find a. Notice that in equation 1, the b term has a coefficient of 2, but in equation 2, the b term has a coefficient of negative 1. I just need the nearest value to b in absolute values to be 2 whole, yeah? So to make here become 2b, don't look at the sign, okay? Just look at the value next to b. To make it become 2b, I will have to multiply the whole of the terms in equation 2 by the value 2. That is the only way to change this to 2b. So I just go straight by saying multiply equation 2 by the number 2. If I do that, I am going to be generating a new equation, which is 2 multiplies 2a will give me 4a, minus 2 multiplies b will give me 2b, is equal to 2 multiplies 5 will leave me with 10. Now this becomes our equation 4, since we already had equation 3 in the earlier beginning. Okay, now notice that equation 4 has a coefficient, that is the absolute number attached to b is 2, and at the same time you notice the same thing in equation 1, that the constant attached to b, or the coefficient of b, is also 2. What it implies is that we can easily eliminate the b term if we work with equations 1 and 4, and that's what I'm going to do right now. So I will be, instead of subtracting, see, if I subtract equation 4 from equation 1, b will not be eliminated, because negative multiplies negative changes it to plus. So instead of subtracting, we are going to add. So we are adding equation 4 to equation 1. So if we do that, a added to 4a will give us 5a, and positive 2b added to negative 2b will give us 0. We have just succeeded in eliminating the b term. Next, we draw our equal to down here and say 3 add 10. That is going to give us 13. So right now we are left with 5a is equal to 13, as you can see here. Since the coefficient of a is 5, we just need to divide both terms on both sides of this equation by 5. And if we do that, the 5 on the numerator, 5a, cancels out the 5 on the denominator, leaving us with a is equal to 13 all over 5. Now, the solution set ends up being that a comma b now is equal to, what answer have we got? A comma b is equal to, a is 13 all over 5, while b is equal to 1 all over 5. So we have ended up solving the first problem, which is a plus 2b is equal to 3 and 2a minus b is equal to 5 using the elimination method. This is how easy elimination method is to use. I am going to use the same elimination method again to solve the second problem so that you get a better mastery of how to work with it. So please pay attention as we deal with our next problem. Our next problem says 2y minus 11 is equal to 7z and 5 is equal to negative 3z plus y. First thing first, I will copy down the question. So first thing first, the first one is 2y minus 11 is equal to 7z. And then the second equation is 5 is equal to negative 3z plus y. Remember I told you in the beginning of the first problem we solved that it is usually better when you arrange your equations in such a way that corresponding or similar terms stand in one column. You get the point. Now if you look at this, you notice that in the first column we have the y term and the constant. This is not how it's supposed to be. So what I'm going to do is to rearrange these equations in such a way that each term stands right under a similar term like it. Okay, so for the first case, which is 2y minus 11 is equal to 7z, I can actually rewrite this as 2y minus 7z. When 7 crosses to the left, it becomes minus, yeah, is equal to, now I'm taking this negative constant, negative 11, to the right hand side, and that makes it positive 11. This is beautiful. Since I have done this, I'm going to play exactly the same role. Now look at this. All I need here is to flip this equation. If I flip this equation, the second one is going to be y minus 3z is equal to 5. So it's going to be y minus 3z is equal to 5. Now the arrangement is proper because you notice that in each column, similar terms stand there, yeah? For that purpose, already achieved, I'm going to call the first one equation 1. I'm going to use A to represent my equation 1, while B represents my equation 2. Now I can successfully apply my elimination skill to work right now. Remember what we did here. So first, I'm going to attempt to eliminate the y term. Since I already have in the first equation 2y, I will try to equate the second one to 2y as well. The only way to achieve that is to multiply the second equation by 2. And if I do that, I'm going to produce a new equation, which is going to be equation C this time. So let's do it. 2 multiplies y to give you 2y, minus 2 multiplies 3z to give you 6z, is equal to 2 multiplies 5 to give you 10. Now I have produced the new equation C. Now notice that in equation C and also in equation A, we have similar term 2y, 2y. I can eliminate. Since both of them are positive, the easiest way to eliminate is to subtract equation C from equation A. Thus, 2y subtracts 2y to give us 0. That one is gone. Do you see that? So let's look at the other terms. This is negative 7z. Subtract negative 6z. This is just the same thing as subtracting 7z from 6z. And that is going to leave us with negative 1z. So I'm writing it down. Negative 1z or negative z equal to, now take a look. Here we have 11 as a constant in equation A. So subtract 10 in equation C from 11 in equation A. That is going to give you 1 whole. Since what we are looking for is the variable z, it is important for us to remove the negative sign attached to it here. And the only way to do that is to divide both sides of this equation by a negative 1. So negative z divided by negative 1 leaves us with z on its own. Is equal to 1 divided by negative 1 leaves us with negative 1. So it means that our value for z equals negative 1. This is solved. Now that we have found the answer for z, it is important for us to find the answer for y. But I'm going to apply elimination again to the same equations A and B, but this time my focus will not be to eliminate Y. I would want to eliminate Z. So I'm going to rewrite equations A and B and apply exactly the same technique that I just applied. Alright, to do that, I come down here and let's write. The first equation was 2y minus 7z is equal to 11. That was our equation A. And our equation B was y minus 3z is equal to 5. This is equation B. Now, since what I want to eliminate in this procedure is z, not y anymore, since I already did that earlier, notice up here there is 7z. Notice down here there is 3z. The only way to equate them is to multiply equation A by 3 and multiply equation B by 7. That will work things out. It's more like using the LCM of 7 and 3. So I'm going to multiply A by 3 while I multiply equation B by 7. Now if we do that, we are generally going to generate two new equations. This time our equations will be D and E since we already have C. So let's do it. Working with 3 into equation A is going to be 3 multiplies 2y will give you 6y. Minus 3 multiplies 7z will give us 21z. Is equal to 3 multiplies 11 will give us 33. This I will call equation D. And then to get equation E, 7 multiplies y to give us 7y. And minus 7 multiplies 3z to give us 21z. And next, equal to 7 multiplies 5 to give you 35. This is equation E. Now we can easily work out things since the middle column is balancing. Since the one above has a coefficient of negative 21 and the one below has the same thing, it is better to alternate the signs by using a minus sign, because only minus will multiply minus to give you a plus. So negative 21 plus 21 will eliminate z. You get the point? So what I'm going to do is to subtract equation E from equation D. Alright, if we do that now, what are we going to achieve? Let's do it. 6y minus 7y leaves us with negative 1y or negative y. Negative 21z minus negative 21z is the same thing as 21z minus 21. That's 0. Equal to 33 minus 35 gives us negative 2. Now, since our focus is to get the value for y and not negative y, we have to remove the negative sign by dividing both sides of this equation by negative 1. When we do that, we are going to arrive at y standing alone, since negative 1 we cancel out the negative in the numerator, so y is equal to positive 2. Now, as a solution set, which I'm going to write on this right hand side, you notice that we have just ended up finding the correct answers for not just z, but for both y and z. We can write our solution set this way. Solution set now becomes y comma z in this equation we just solved is equal to our y give us the value 2. So our y comma z is 2 comma, what's the z value? The z value is negative 1. So y comma z is 2 and negative 1. This is our final answer. Did you see how swift it was and how simple the method also was in application? It is important for you to attempt these methods that we have just shown to see how well you will do and how well you have been progressing. I hope it helps. Thanks a lot for watching.